Now we're going to talk about multiplication in polynomials. Before we were doing addition and subtraction of polynomials. Now we are going to do a bunch of examples where we multiply. And we already actually have quite a lot of practice with this. It's very similar techniques. We are just going to have to use some new rules. So let's say that we want to multiply 4a cubed by this polynomial, 3a squared minus a plus 1. So the technique here is to still use the distributive property. So we will distribute this polynomial in and multiply each of the terms of this polynomial. So we will have 4a cubed, and let's do that systematically, 3a squared. So I won't just simplify. I'm going to write it out, and then we'll simplify each of the terms. So 4a cubed is going to multiply this first one, and then it will multiply the second one. So we'll have plus 4a cubed times minus a. And then we will have plus 4a cubed times plus 1. All right? And now let's simplify this whole thing. Now, when you have these two factors, we're going to multiply the coefficients, so we'll have 12. And how do you multiply terms like this? Well, the rule is that, you know what, let me write them next to each other and then I'll explain the rule first. Okay, so we have these two things that we're going to simplify in just a second, but let's do that to all the terms. So the 4 and the minus a multiply to give us minus 4, right? So this plus, you could just write it as a minus right now. Maybe we'll do that actually. So okay, so this is actually a minus 4a cubed times a, and plus 4 times positive 1 is a positive 4a cubed. Okay, so we're trying to figure out how to simplify these two expressions. Well, the rule is that if you have, if you're multiplying powers together, so let's say that your power is n and m, then when you multiply these, you will add the exponents together. So that's the rules. Those are the rules of combining exponents. In this case, our polynomials are in a, so the rule would be, it would look like this. It would be a to the n plus m. So the rule is just saying that when you multiply terms together and they have this common base here, you're just going to add the exponents. We'll have 2a to the 3 plus 2. So that'll actually be a to the 5th. And then we'll have 4a to the 3rd plus, and then this exponent is actually a 1, right? And this is already simplified. So in the end, we will get 12a to the 5th minus 4a to the 4th plus 4a cubed. Now let's multiply these two. So we have a plus b times a squared minus ab plus b squared. So how do we do this multiplication? So the original technique, and we have actually seen examples like this before, is to again just use the distributive property. All right, so let's do that and see what we get. So we would have a plus b times a squared, and then we will have plus a plus b times ab. If you want, you can actually put these factors afterwards. So if it's a little confusing how I'm writing this, you could write this. You could write minus ab times a plus b, right? So the a plus b, it doesn't actually matter what side you put that on because the multiplication is commutative, but if it's easier for you to see this distributive property, you could always write it on the right side. Okay. So then what? Well, we would have to distribute in these terms. So the a squared gets distributed, and the minus ab gets distributed, and then the b squared would get distributed. Okay, so distributing in the a squared, you will have a squared times a, and you will add those exponents together. So you will have a cubed, right? And then you'll have plus a squared b. And then this minus ab gets distributed, and you have minus a squared b, right? Because you have two of the a's, so you have a squared. And then you will have minus a, and now you have two of the b's, so b squared. And then the b squared gets distributed, so b squared a plus b, and then now you'll have three of them, right? B squared times b to the 1, you add those exponents, you have b cubed, right? Can we simplify this at all? Do we have like terms? Well, let's see. Do we have any other a cubed terms? It doesn't look like it. Do we have any a squared b terms? So a squared b, we actually do, right? You see that this term and this term are actually the same, so they would cancel. Any other a squared b terms? No, it doesn't look like it. But what about b squared a terms? So this is actually the same term as this. Remember, the multiplication order is irrelevant. It's what is in the factor is important. So those two will be able to combine. And b cubed, there's no other b cubed term. So what do we have? We have an a cubed. And then these two are actually negatives of each other, right? So those cancel, right? So these will actually cancel. And then what about these? This is ab squared, and this is b squared a. But that's the same thing. I could write the a over here because multiplication is commutative, and then I'd have ab squared. So these are also negative. So these would also cancel, and you're just left with the b cubed. So that would be our answer. Now, what about this one down here? Well, using the same technique, we will distribute this in. And what will we get? So we will have x squared times this term, x minus 3y. We will have plus 3xy times this term, x minus 3y. And we will have plus 9y squared times this term, x minus 3y. And now we will have to distribute each of these. So the x squared will get distributed, and we will have x cubed, right? Because this is essentially x times x times x times x, so that's x cubed. Or you could use the rule where you add the exponents. Then we'll have minus 3x squared y, and then plus, distributing this in, we will have 3x squared y, and then distributing 3xy with minus 3y would give us minus 9x, and then the y's will combine to give us y squared, and then plus 9 y squared x, and then minus, so 9 times 3 is 27, so minus 27, and then y cubed. And then now we have to simplify this. So looking at x cubed, are there any other x cubed terms? No, so that would just be x cubed. What about terms that have x squared and a y? So two x's and a y. X squared y, x squared y. Nope, only one x, no x's. So these two would combine, and they're negatives, so those cancel actually, right? And then this is 9xy squared, and this is 9y squared x. But the terms themselves, there's 1x and 2y's, 1x and 2y's. So those can be combined, but they're negatives, so these will cancel. And we're just left with this minus 27y cubed. And that would be the answer. In this next example, we want to use this method of FOIL that we actually did talk about before. But so what is this again? So FOIL, this is first, outside, inside, last. So it's just sort of a reminder of how you can multiply binomial terms together. So if you ever have two factors that have two terms in them, and you want to multiply them, you can remember this. And the procedure is as follows. So the first multiplication would be to do x times x. That would be first, the outside term would be x times -3 because these are the outside terms. The inside would be 2 times x, and then the last two, because of the last two terms, would be 2 times -3. So again, so first x times x would be, that would be your f. First, outside would be x times -3. Plus the inside 2 times x. That would be the I. And last would be 2 times -3. And then now we just simplify this expression. So we'll have x squared minus 3x, and then plus 2x minus 6, and then this simplifies to x squared. And these two are like terms, so we just combine the coefficients. So -3 plus 2 is -1, so that would be minus x, and then minus 6. Doing the same thing for a little bit more complex term, look at this. So first would be 6x times 2x. Then the outside terms would be 6x times minus 3y. The inside would be -5y and times 2x. And then the last would be minus 5y minus 3y. So you could skip writing all these multiplications out and you could immediately just determine what they are, but let's simplify these. So this would be 12x squared, and then plus it'll be -18xy, and then minus 10xy, and then negative is plus 15y squared. And we have only this term with x squareds. These two terms have an x and a y, so we could combine these, but this is the only term with a y squared. So in the end we'll have 12x squared and then minus 28xy plus 15y squared. Similarly for this next example, first two terms, maybe we could just try to multiply them instead of writing them out. So if you want to write out the terms like we did up here, you can do that, but let's just try to do the multiplication out now that we're a little bit used to this. So 5a times 2a would be 10a squared. The outside terms, 5a times positive 1 would be plus 5a. -4 times 2a would be minus 8a, and then -4 times positive 1 would be minus 4. And the only simplification that we can do is these two terms have a's in them, so we would have 10a squared, and then that would be minus 3a minus 4. For this next example here, we have 3x minus 4y squared. So one way that we could start this is we could actually just write that out as two factors. So 3x minus 4y, just write it twice since that's the same thing as this squared. And then now, I didn't specify the method to use, so you can use whatever you want, but it seems like this FOIL procedure is pretty quick, so let's try to do that. So first, we'll have 3x times 3x is 9x squared. The outside 2 will be 3x minus 4y is minus 12xy. The inside terms, minus 4y times 3y would be minus 12, and then xy. You could write yx, but it's the same as xy. And then minus 4y times minus 4y would be positive 16y squared. And these two terms we can combine because they're like terms. They both have an xy in them. So we have 9x squared minus 24xy plus 16y squared. So for this term, what should we do? So we have 5r squared minus 2s, 5r squared plus 2s. Let's sort of continue with this FOIL procedure. We have these two-term multiplications that we're doing, so we can try to do this. So 5r squared times 5r squared would be 25. R squared is rr. So if I'm multiplying those, I'm going to have 4 of them, right? So r to the 4th. And the outside, we will have plus 10, r squared s. And then the inside, we will have minus 10. And we also have r squared s. If you write s r squared, that's still going to be the same term. I'm just writing it so it's consistent. And then this multiplication, we will have minus 4s squared, right? And then we can combine these two. So we'll have 25r to the 4th, and then they are actually opposites, so those are going to cancel, and we're just left with minus 4s squared. And then finally, we want to expand and simplify this expression here. So just like we did in the previous one, we could rewrite this term as x minus 2 times x minus 2. So then we could do the foiling, but let's just continue to keep rewriting. 3x minus 2 minus 10. Okay, so for this, we will FOIL. And then what are we going to do for this one? So let's FOIL this. And then this one, we will just do a normal distributive property. Okay, so maybe let me rewrite the thing before doing FOIL, and we'll FOIL it. But here we will have a minus 3x and then a plus 6 after distributing minus 3, and then we'll have the minus 10. Okay, so now let's FOIL. So we'll have the first two will be x squared. The outside is minus 2x. Inside is minus 2x. And then the last two terms, minus 2 gives us plus 4. Minus 3x plus 6 minus 10. And then now we have a bunch of terms that we're going to combine. This is the only one with x squared, but this has an x, this has an x, this has an x. So we can start with x squared, but then minus 2 minus 2 minus 3 is minus 7. So minus 7x, and then we have a 4, 6, and a 10, right? So 4 plus 6 is 10, but then minus 10 makes that 0. So it looks like that is going to be the final answer.